All right, so 2.5, solving equations by factoring. Okay, so we're going to finally kind of get to see some of this. It's not really quite application yet, but um, it's just, it helps give you a little bit more insight to how factoring could be useful. Okay, so before we can do that, though, we're going to have to look at this thing called the zero factor property. The zero factor property basically is that 0 times any value equals 0. So basically, if you take 0, you multiply it by any number you want, it's going to equal 0. And that hopefully should seem pretty obvious, right? 0 times anything would be 0. So the way that's going to help us out here is if you look at our first example right here, it says solve the following quadratic equations. So real quick, what's a quadratic equation, right? Well, this is how they typically look. If you look down here at number 15, that's typically how a quadratic equation looks. And basically what's going to make it a quadratic equation is it has an exponent of a power of 2, okay? Can't go higher than that. It must have a squared, and then it can have a, you know, just a regular variable here without, understood power of 1, and then a constant. That's how most of them are going to look, okay? So quadratic equation is just that you're going to have a squared variable. Now, if you have a, to get kind of technical, if you were to add on like a y to the third power, all of a sudden that's not a quadratic anymore. So even though you have a y squared, if I introduce a y to the third power, that would not be considered a quadratic. Okay. Okay, so basically, quadratics are going to be what we've been dealing with lately from our notes when we've been factoring. Okay, so the zero factor property, the way this is going to work, so to kind of make sure we see this, so what we have going on in this first one, we have an x plus 3 parentheses times x plus 5 equals 0. So what's going on here is they're getting multiplied together, just like I have right up here. So what I'm going to do is ask myself, okay, well, what would make that first factor equal 0? What would make that equal 0? And you should be able to solve that pretty easily. You would subtract 3 from both sides, and it'd be x equals negative 3. If I were to let x equal negative 3, this would turn into a 0. Now, this would turn into a 2 over here. This would turn into a 2, but that would make no difference because I'd end up with 0 times 2. Well, 0 times 2 would be 0, right? So that's one of my answers, right? But now I'm going to look at, well, what would make x plus 5 equal 0? And once again, this should be pretty simple to solve. We'll subtract 5 from both sides, and we get x equals negative 5. That's my other answer here. So I actually am getting two answers, and that will happen a lot with quadratics. Not always. Sometimes you only get one answer, and we'll see that example in a minute. But most of the time, you actually get two answers for quadratics. So my answer, if I let x equal negative 3 or a negative 5, it would cause it to equal 0. It would cause it to equal 0. Now, when you're doing your homework, what's going to happen is they'll already have them there for you, but you'll have these little braces right here, and you just type in your answer and just put a comma between them. And it doesn't matter what order you put them in. It doesn't matter which one you put first, okay? But yeah, so our answer set, this is called a set, our solution set is negative 3 and negative 5. Either one of those would work if you were to plug it in. It would satisfy the equation. All right, let's look at another one here. Okay, so if you look at our next example, what's going on here is you have 5 times x times 10x minus 3 equals 0. Okay, so once again, I'm trying to figure out what will make this equation equal 0. And so I have a 5 here. Not really anything I can do about the 5. A 5 is a 5, okay. But, you want to look at each factor individually, and that's whatever, that's each term separated by multiplication. So we've got a 5, we've got an x, and then we have times 10x minus 3. That's in parentheses, so that all goes together. So you look at each one. Okay, so the 5, I can't really do anything about the 5. But the x, what could I do to make that 0? Well, I could just go ahead and make it 0, right? There we go. That's actually one of my answers right there. If I were to let x equal 0, I'd end up getting 5 times 0, which would be 0, and then times, if I plugged in 0 here, I'd get something, but it doesn't really matter because 0 times any number will equal 0. So that's one of my answers. And then now I got to look at this factor right here, 10x minus 3. I wonder what would make that equal 0. And so let's see, this is going to be 2 steps here. I got to add 3 to start. So let's see, I end up with 10x equals 3. And then we'll divide by 10. And so we get x equals 3 over 10. That's my other solution. So that's my solution set, 0 and 3 over 10. Either one of those, if I plug it in, would cause this equation to equal 0, the left side to turn into a 0 and satisfy the equation. All right, my last example of the 0 factor property right here is x plus 4 squared equals 0. Okay, well, let's see. What am I going to do here? I want to figure out what makes this equal 0. Well, my expression x plus 4 on the left side is being squared. Well, let's think. 0 to the second power would be 0 times 0, which would equal 0. Okay, so I just need to figure out what will make that expression inside there equal 0. So x plus 4, set that equal to 0, and then I'll solve it. And so I get x equals -4. And there we go. That's my solution. So this one, I actually only got one solution this time, okay? So as I mentioned earlier, most of the time we'll actually get 2. It is possible that you only get 1, okay? And I don't really want to go past saying that right now, okay? So right now we're going to focus on mostly getting 2. Sometimes we get 1. You might be thinking, is it possible that you don't get any? And the answer is there's a kind of a gray area because we introduce a new concept at that point. And so we'll wait on that for right now. All the ones we're going to look at right now, we're mostly going to get 2. Okay, so now what we're going to do is really nothing new, okay? Now that we've seen the 0 or the 0 factor property, now what we're going to do is we're going to combine what we've been doing previously with that concept. We're going to start out with a polynomial, and what we have to do is set it equal to 0, which this one is, okay? And then, and I'm kind of going over these directions right now, you want to rewrite it in general form, which is right here, and ours is ready to go, okay? Basically, if not, you would have to move things over and put it in descending order of powers. And so if you look at problem number 19, that's one of those that we're going to have to do some adjustments because it's not set equal to 0 yet. We'll deal with that in a moment. Then step 2 is to factor completely. Always look for GCF first, okay? Then we're going to apply the 0 product principle, which that's the same thing as the 0 factor property. Those are interchangeable. They're the same thing. And then setting each factor containing the variable equal to 0. Then solve it. And there you go. You'll have your solutions. So we're going to start on number 15. We have to start by doing the A&M method. A&M. So what multiplies to give us 2, but add up to 3? That should be pretty easy. 2 and 1, right? 2 times 1 is 2. 2 plus 1 is 3. So we're going to factor this into y plus 2 and a y plus 1 equals 0. Okay? And then now it's exactly like what we were doing up above. You take each factor and set it equal to 0 and solve. So we'll subtract 2 on both sides on this one, and subtract 1 on both sides on the other one. And we've got our 2 solutions. So -2 or -1, right? Either one of those would satisfy the equation. So that is my set of solutions, my solution set right there. All right, let's try another one. I mean, these first couple seem fairly simple. The factoring doesn't look too bad. So let's see, we're going to do the A&M method here. So let's see, multiply give us 3, but add to give you 4. So two numbers that multiply to give us 3, but they add to be a negative. So they must both be negative. And really, I only have one option, -1 and -3. Those multiply to give me 3. They add to give me -4. So we're going to get r minus 1 and r minus 3. And then we take each one, set it equal to 0, and solve. So let's see, we'll start by adding 1 to both sides. R equals 1 here. Add 3 to both sides. R equals 3. So our solution set is 1 and 3. Okay. All right. Let's see. So this next one, number 19, you can see it's not in the right, it's not in general form. It's not in the right form. So you might think, oh, I'll just move the x squared over. You could do that if you want. But I like to keep my squared value positive. And even if I moved it over to the right side, there could be some ways to adjust it, right? But what I'm going to do is I'm going to instead put everything on the left side, okay? So what I'm going to do is I'm going to go ahead and I'll do this in 2 steps just because I don't want to lose anybody here. We could do it all together in 1 step if we really wanted to, but I'm going to break it into 2. So I'm going to start by adding 5x to both sides. So the minus 5x plus 5x nullify each other on the right side. Now on the left side, I have an x squared plus 5x. Those are not like terms. Do not try to add them together, okay? We've talked about this before. So leave it as x squared plus 5x, and then on the right side, I still have a 24, okay? And then my next step will be to go ahead and subtract 24 from both sides. So subtract 24, subtract 24, that cancels out. So we're going to get x squared plus 5x, and then minus 24 equals 0. And then now we're ready to actually go ahead and solve this. So that will be a reoccurring theme that we're going to see, is that if it's not set equal to 0 and it's not in general form, do whatever it takes to get it into that format. So you'll see as we move forward, some of them there'll be even a little bit more that we have to do to kind of get it into this format. It's not a big deal, but just a little heads up. Okay, so A&M method, so multiply to give us -24, but add up to 5. So it adds to a positive, but multiplies to a negative. So one's positive, one's negative. I believe, let's see. Guess that's going to be a positive 8 and a -3. Okay, so we'll go ahead and factor that. X plus 8, x minus 3 equals 0. And then we'll take each one of those, set it equal to 0, and solve. And so I know a lot of y'all are probably thinking, oh, I could do that part in my head. You know, if you're comfortable with that, that's okay. But a lot of times students, you know, they'll do it, but then they don't really, later on, they don't remember why they're doing it, you know? And so the main thing is I want to make sure you understand, you know, why is it -8 and +3? Because a lot of times students just try to remember, oh, it's the opposite. But why is it the opposite? It's because these values cause the factors to equal 0, okay? And then the product, when you multiply 0 times anything, you get a 0, right? So it's always, to be honest, you know, it's a little bit more work to understand the concepts, right? But then you don't have to memorize them. You understand it. And so I always try to preach that to the students, that take a little time to make sure you actually understand it. And then there's not really any of the memorization you have to have, because you get it, you know? All right, let's try a couple more of these. So number 20 is pretty similar to the last one we did. So I'll go ahead and do both of these at the same time. So I'm going to subtract 2t, and I'm going to subtract 15 at the same time to save a little bit of time and space. So the right side's going to get completely canceled out, because 2t, take away 2t, so it's gone. Plus 15 minus 15, gone. Now on the left side, we've got a t squared minus a 2t minus a 15, and then the right side is 0. And then now we are back to our A&M method. Okay, so what multiplies to give me negative 15, but add up to negative 2. Once again, I'm dealing with one positive, one negative. Let's see, I believe this time it's going to be a negative 5 and a positive 3. Those multiply to give us negative 15, adds to negative 2. So let's see, t minus 5 and t plus 3. Okay, and then we'll take each one of these and set them equal to 0 and solve. And I'm kind of running out of room, so I'll just go ahead and write my solution set. So it should be a positive 5 and a negative 3 right there. That's what we're looking at. Okay, on 23, this one, once again, we kind of have to put it in general form. We only have to do one thing here. We're going to go ahead and add 2 to both sides. So we end up with z squared plus 3z, then plus 2 equals 0. And then we're going to do our A&M method, which in this particular example is not too bad. Should just be a 2 and a 1. 2 times 1 is 2. 2 plus 1 is 3. So z plus 2, z plus 1. And then I'll just go ahead and put our solution set again. So it should be a negative 2 and a negative 1. So as you can see, I'm starting to kind of take a little shortcut right there. Just kind of depends on your comfort level, right? So see, if I plug either one of those in, it would cause it to equal 0. And also, just to make sure we understand the concept, if I plug it back in here, if I plug in either one of these, it will equal negative 2. If I square it and then plus 3 times z, whatever I plug in, whichever one, it will equal negative 2. If you don't believe me, go ahead and do it. So that's kind of where the factoring comes in, because think about what they're asking. Some value squared plus 3 times that same value equals negative 2. I mean, that's almost, I wouldn't say it's an impossible question without factoring, but it's a tough one. If you weren't allowed to factor, you might be here for a while trying to figure that out. Especially because right now the answers are nice. Our answers are nice. They're not always going to be nice. Sometimes they're going to be fractions. So just kind of keep in mind what are we actually doing. We're actually solving an equation right now. Okay, let's try a couple more. So let's see, if we're looking at number 25, so let's see, A&M method. It's already ready to go. So multiplies to give us 16 and add up to 8. That's going to be 4 and 4. That's actually that's a perfect square trinomial. So it's m plus 4, m plus 4. Or if you notice it was a perfect square trinomial, you could have taken the shortcut. So you notice the factors are the same. So you're only going to get one solution. And if you want to, we can go ahead and write it as m plus 4 squared equals 0. And we saw an example like this for when we introduced the zero factorization property. So we just have to take this, set it equal to 0 and solve. And so in this particular example, the solution is negative 4. Okay. All right, our next example, let's see, I got to start by adding 4 to both sides. So let's see, we're going to get 9. I'm not a big fan of using s as a variable, but that's what we got here on this one. Let's see, plus 4 equals 0. Now, you might be thinking, oh man, I got that value in front of that squared. I got to do 9 times 4. And you can go ahead and do that if you want. It will definitely work. It will definitely work, okay? But I notice that my edges are actually perfect squares. So that's the same thing as 3s squared, and that's the same thing as 2 squared, right? And let's see, is the middle is supposed to be 2 times a times b. See, 2 times 3s is 6s times 2 is 12s. It checks out. So actually, I can take the shortcut on this. This is going to end up being 3s plus 2 squared. Okay, now you might be a little lost. You might be like, what the heck? This is from the last video. So hopefully you saw the last video we had perfect square trinomials, and this is a perfect square trinomial right here, okay? And if you don't want to do it that way, that's fine. You can do 9 times 4 is 36, and you can split the middle and do all that if you really want to. But I happened to notice that it was a perfect square trinomial, so I went ahead and did it that way. And you can see I did it very fast, okay? So that's just one of the things, you know, if you like shortcuts, I mean, it'll take time. Kind of like I said, you got to put in the time to understand it, but then you won't have to memorize it. You'll start to notice these things, okay? But either way, we need to go ahead and finish solving this. Now, this one has got a little bit more going on, so I'm going to come over here. Let's see. So I'm going to take this and set this equal to 0. 3s plus 2 equals 0. And I need to solve that. So I'm going to start by subtracting 2 from both sides. And then I'm going to divide by 3 on both sides. So we get s equals negative 2 thirds. So that's our solution set. So that one only had one solution also. Okay, so now we looked at perfect square trinomials. Now we are actually going to look at difference of two squares. Okay, these are a little bit easier in my opinion. So right here, this is y squared, and I can write this as minus 3 squared. So I have the difference of two squares. So if y'all remember this, I'll write it down. A squared minus b squared. You can write it as a plus b, a minus b. So that's the pattern here. If you can get this, then you just take the bases, do one with plus, one with minus, and that's what we'll do here. So y plus 3, y minus 3. And then we'll take each one of these, set those equal to 0, and solve. And so your solution, oops, I didn't mean to grab that. Let's see, so my solution set is going to be negative 3 and positive 3. All right, we'll do one more and then we'll cut this off and I'll make a part 2 video. So let's see. This is pretty similar to the last one, a little bit more in depth with the bases. So I got to figure out something squared minus something squared equals 0. So looking at the 16k squared, let's see, what squared gives me 16? I believe that's, what, 4, right? 4 to the second power 16. And then I'm going to take a k with it. So that squared is 16k squared. And then let's see, what squared gives me 49? I believe that would be a 7, right? So now we'll go ahead and break this into, 4k plus 7, 4k minus 7. And then we have to take each one, set them equal to 0, and solve. Oops. Okay. So let's see, 4k plus 7 equals 0. 4k minus 7 equals 0. So we're going to subtract 7 from both sides. So 4k equals negative 7. Here I'm going to add 7 to both sides. So 4k equals 7. And then we're going to divide by 4 on both sides. Well, everywhere. That cancels out. So one of my solutions is negative 7 over 4. And then my other one would be positive 7 over 4. So that's my solution set right there. All right. Okay, so this will be a good stopping point. I do have a couple more slides. Really, the examples kind of look similar to this. I believe we'll get into some where the leading coefficient's a little bit larger, but the idea is the same. We're still using this concept with the zero factorization property to kind of help us out here.